Let's take an example to show how to find the inverse of a matrix using Gauss Jordan. We have A, which is a 4x4 matrix. Now, to find the inverse of A, we are going to have the row reduced form, or we are going to find the row reduced echelon form of A. But while trying to find the row reduced echelon form of A, we are going to be applying the same operations we do on A on the identity matrix. So we will write our matrix as such. We have A and the identity matrix placed side by side. So we have A slash IN, in this case is I4, and this is what we have. There's A, this is the identity matrix, and these are our rows 1, 2, 3, 4. So every time we do an operation here, we do it 2 on this side. Now, to obtain the row reduced echelon form of this, we pass through the echelon form first. And to get the echelon form, we have to make sure that all these elements turn to 0. To have zeros on all these positions, we can make use of the fact that we could do the row or the elementary row operations. Now, we have 1 on this position, so 1 minus 1 gives us a 0. With this, we can have R2 becoming R2 minus R1, and we have 1 minus 1 gives us 0, 1 minus 0 gives us 1, 0 minus 2 gives us negative 2, 0 minus 0 gives us a 0. What you have to notice here is all operations done on this matrix will be replicated on the identity matrix. So the identity matrix is just going to follow the rules. We have 0 minus 1, negative 1, 1 minus 0, 1, 0 minus 0, 0, 0 minus 0, 0. To obtain a 0 here, we have to subtract, or we can subtract with R1 or with this row. In this case, we could also subtract with R2. So now we have 1 minus 1, which gives us 0. And 2 minus 0 gives us 2. 0 minus 2 gives us negative 2. 1 minus 0 gives us 1. Then 0 minus 1, negative 1. 0 minus 0, 0. 1 minus 0, 1. 0 minus 0, 0. To send this to 0, you can see that 1 minus this 1 gives us 0. With this, we have R4 becoming R4 minus R2, and we have 1 minus 1 gives us 0, 1 minus 1 gives us 0, 1 minus 0 gives us 1, 1 minus 0 gives us 1, 0 minus 0 gives us 0, 0 minus 1, negative 1, 0 minus 0, 0, 1 minus 0, 1. Our next step will be to convert this 2 to a 0. In fact, all elements below the leading entry to 0. So we have to swap R3 with R4. This is optional, as you can pass through another elementary operation to have the echelon form and the row reduced echelon form. So this is just our method, and there are other possibilities. So swapping, we have 0, 0, 1, 1, which leaves from R4 to R3, and 0, 2, negative 2, 1, which leads from R3 to R4. The same is done on this other side. So we have 0, negative 1, 0, 1, which comes this way, negative 1, 0, 1, 0, coming this way. We continue with our operations. We have R2 equals R2 plus 2R3. So we have this equals this plus 2 times R3. Now R3 is actually this. Now 0 plus 2 times 0 is 0. 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1 is 0. Obviously, you see that the reason why we are doing R2 plus 2R3 is because 2 times 1 is 2 and negative 2 plus 2 times 1 is a 0. This would permit us convert this negative 2 to a 0. Now we have a 0 at this position, and 0 plus 2 times 1 is a 2. Next we have R4 equals R4 minus 2R2. So we have 0 minus 2 times 0 is 0. 2 minus 2 times 1 is 0. So we've also made sure that all these numbers below the leading entry are zeros. Then we have negative 2 minus 2 times negative 2, which gives us a 2. 1 minus 2 times 0 gives us 1. We do the same operations on this other side. Negative 1 minus 2 times negative 1 is 1. 0 minus 2 times 1 is negative 2. 1 minus 2 times 0 is 1. 0 minus 2 times 0 is 0. We are one step to converting this matrix into the echelon form. And to do this, this 2 has to turn into a 0. So we have R4 equals negative R4 plus 2 R3. These kind of operations are also possible, wherein you have a constant multiplied by the line or the row number plus a constant multiplied by another row number. This kind of operation actually is a combination of two operations. One wherein you add a line to a scalar multiple of another line or another row, and the other where you multiply the row by a constant. In this case, the constant will multiply the row R4 where it is negative 1. So it's a combination of two operations. With this, 0 becomes negative 0, and we have negative 0 plus 2 times 0 giving us 0. We have negative 0 plus 2 times 0 giving us 0. We have negative 2 because we have negative R4. Negative 2 plus 2 times 1 gives us 0. We have negative 1 plus 2 times 1, which gives us 1. We have negative 1 plus 2 times 0 gives us negative 1. We have negative 2 plus 2 times negative 1, which gives us 0. We have negative 1 plus 2 times 0, which gives us negative 1. We have negative 0 plus 2 times 1, which gives us 2. In the next step, we are going to make sure that this 2, 2, and 1 turn to 0 for us to have the row reduced echelon form. Since here we already have the echelon form, and it's clear that the number of pivot columns equals 1 because we have 4 pivot positions of 4 pivots, which are 1, 1, 1, and 1. Good enough, we already have 1s on the pivot positions. So what's left to do is converting this, and this to zeros. So let's move on. We have a 2 here, so subtracting by 2 times this 1 will give us a 0. And since we already have zeros up to this position, the 0, 1, 0 remain unchanged. So with this we have R2 minus 2 R4, and we have 0 minus 2 times 0 giving us a 0, 1 minus 2 times 0 giving us 1, 0 minus 2 times 0, 0. 2 minus 2 times 1, we have a 0. Next, we have negative 1 minus 2 times negative 1, we have 1. Negative 1 minus 2 times 0, we have negative 1. 0 minus 2 times negative 1, we have 2. 2 minus 2 times negative 2 minus 2 times 2, we have negative 2. So we have succeeded in taking this element to 0. Then we have 1 minus 1, which gives 0. And all these elements are zeros. So we can be sure that from 0 to 1 is going to be invariant. Now we have R3 equals R3 minus R4. So we have 0 equals 0 minus 0. Then 0, which is actually equals 0 minus 0, 1, 1 minus 0. And then to obtain this 0, we have 1 minus 1, giving us 0. For the rest, we have 0 minus negative 1, giving us 1. Negative 1 minus 0, giving us negative 1. 0 minus negative 1, we have 1. 1 minus 2, we have negative 1. What's left to do is converting this 2 to a 0. It's clear that if we work with this third column, we'll be able to do that very easily, given that the first, or rather the second column, doesn't have any number different from 0 on this level. So there is no possibility of turning this to 0 using R2. Same for R4. So R3 is the best candidate. With this, we have R1 equals R1 minus 2R3. So we have 1 minus 0 gives us 1. 0 minus 2 times 0 gives us 0. 2 minus 2 times 1 gives us 0. 0 minus 2 times 0 gives us 0. And 1 minus 2 times 1, negative 1. 0 minus 2 times negative 1, 2. 0 minus 2 times 1, negative 2. 0 minus 2 times negative 1, 2. This matrix has been reduced such that we have the row reduced echelon form. Now, given that all operations carried on A had been carried on In right from the beginning, you will find that this matrix turns out to be the inverse of A. So, to invert A, or to find the inverse of A, you simply find its row reduced echelon form and apply the same rules on the inverse. And once you have the row reduced echelon form, this matrix to the right becomes the inverse. So our inverse is equal to this 4 by 4 matrix, and that's how we find the inverse of a matrix. So you're going to exercise yourself. You have A1 equals this 3 by 3 matrix. You're going to be finding A inverse, A1 inverse. For the second example, you have a 2 by 2 matrix. But this matrix is special in the sense that we don't have some particular real numbers. We just have real numbers, arbitrary, which are A, B, C, and D, which are actually variables. Now, find this inverse and deduce the inverse of any 2 by 2 matrix. Finding this inverse will help you be able to find the inverse of any 2 by 2 matrix, because this inverse will be found with respect to these numbers A, B, C, and D. So if these numbers are replaced by some number, say 1, 2, 0, 5, you'll just apply these numbers to a formula you must have gotten from solving this exercise. So good luck in solving this exercise. See you in the solution. After finding A1 inverse, you should have this as answer. For A2, we have A, B, C, D, and by its side, I2. The identity matrix for a 2 by 2 matrix. Now, we have to turn this to the row reduced echelon form. Firstly, we have to struggle to convert this C to a 0. I noticed that if I'm able to somehow get rid of this 0, I'll have the echelon form. To get rid of this to have a 0, we can do R2 equals R2 minus C on A R1. Reason being that if I have this C minus C on A times A, I'm gonna have a 0. C on A times A is equals to C, and so C minus C is 0. So with this we have R2 equals R2 minus C on A times R1. C minus C on A times A, 0. D minus C on A times B. If you calculate, you have AD minus BC on A, and 0 minus C on A times 1 is negative C on A. 1 minus C on A times 0 is a 1. Now we can go ahead to turn in this number to a 1, this to a 1, and this to a 0. To do this, we can start by turning this B to a 0. If I multiply AB on AD minus BC, this here, by AD minus BC on A, I'm gonna have a B. So multiplying this by this gives me a B. B minus a B gives me a 0. So what I do is I have R1 equals R1 minus AB on AD minus BC times row 2. With this we have A becoming A minus AB on AD minus BC times 0, and this gives me A. Next we have B minus AB on AD minus BC times AD minus BC on A. Putting AD minus BC on A, this way you have B, and B minus B is a 0. Then we have 1 minus AB on AD minus BC times negative C on A, which gives me AD on AD minus BC, followed by 0 minus AB on AD minus BC times 1. So I have negative AB on AD minus BC. So with this, we have converted this B to a 0. What we'll have to do is convert A to 1 and AD minus BC on A to 1. Now, we will simply multiply row 1 by 1 on A, because 1 on A times A is a 1. So here I have R1 equals 1 on A times R1, and we have A times 1 on A, which gives us 1. 0 times 1 on A, which gives us 0. AD on AD minus BC times 1 on A, which gives us D on AD minus BC, minus AB on AD minus BC times 1 on A, which gives us negative B on AD minus BC. We move to the next step, where we divide or multiply this by A on AD minus BC. A on AD minus BC times this gives us a 1, and that's what we have here. Now, A on AD minus BC times negative C on A gives us negative C on AD minus BC, and A on AD minus BC times 1 gives us A on AD minus BC. So with this, we have the row reduced echelon form of ABCD, which is this and its corresponding inverse. So in general, the inverse of any 2 by 2 matrix has this form. Now what we've done is we've factored out the the 1 on AD minus BC. So here we have 1 on AD minus BC, which is common here, here, and here. And once we factor that out, we have 1 on AD minus BC into this matrix made of D, negative B, negative C, and A. What does this mean? This means that if given a matrix, say 1, 4, 8, 7, all you need to do is put these numbers in this formula. And by doing that, we have A inverse equals 1 divided by A, which is 1, times D, which is 7, minus BC. B is 4 and C is 8, so minus 4 times 8. All this times the matrix D negative B negative C A. D is 7, A is 1, so we put 1 this way, negative B, 4 tends to negative 4, and 8 tends to negative 8. So a simple rule of thumb is AD minus BC. So with this, you have the diagonal minus the other diagonal into the diagonal swapped, and the other diagonal just changed sign. So you change the sign of the other diagonal and you swap the diagonal. So with this, you can always find the inverse of a matrix quickly without necessarily memorizing this formula. We've come to the end of this section on matrix algebra. We now know how to manipulate matrices, and in subsequent sections, we shall see how to use these skills in solving a host of applications. You can ask as many questions as possible on the forum, as these questions will be answered as quick as possible. So feel free to ask them and make sure you understand every concept before moving to the next section. Thank you for being with us, and see you in the next section.